Welcome to my Physics 2211 Lab 5 presentation. The purpose of this lab will be understanding the physics of a Haynes-King rocket. We'll be using the momentum principle and velocity update, as well as the energy principle and specifically kinetic energy. A little preview of the results. My model came out pretty accurately to my measured results, but we'll get into that in a little bit. The experiment, we have the throw by Haynes, sometimes the GOAT King, as he beats Miami. If you haven't seen it, here it is.
Here's King from the pocket. Flush to his right with 6-5. Gonna loop it downfield. And ball is caught. Touchdown.
Just a dime. If you're a fan of football, you love seeing that. Haynes launches this rocket down the field. We're going to track the ball in the tracker app for the first half of the arc. We're going to use the data gathered from that to find velocities, energies, etc., and use this to estimate where the ball will land. The system will be Haynes-King, the Earth, and the football itself, of course, the surroundings being the air. The initial conditions, the football mass is about 0.4 kilograms, a standard NCAA football. The position of the football in my coordinate system, about 1.2 to 2.9 x and y meters respectively. And the initial velocity of the football when he launches that, 20 meters per second in the x direction, 9 meters per second in the y direction. Incredible throw. Now for the model in my code, the steps will be: first, create an object in the code with the initial conditions listed for the football. Second, calculate the forces acting on the football. Third, update its velocities and position. Fourth, you're going to iterate those 2 and 3 steps for the entire given time interval. Here's a snippet of the code. This is just the core, the most important part. This is heavily inspired by Lab 102, I forget which one, but the result from tracking the actual video though are these graphs. As you can see on the left, we have the X, and it's basically a linear trend upward. There's some wave in there. We'll get to the arrow later, and then the Y on the right hand side. You see we have the first half of a parabola. These are both as expected. Now, plugging in values into the simulation in GlowScript, those will be the blue curves on these graphs. As you can see, they line up pretty well with what was measured in the video itself, actually. Now, after running the simulation, this is the full chart of when the ball has completed a full arc of the parabola going from height 0 to height 0. It has the ball reaching about 40 meters, roughly 36 yards or 37 yards downfield. Now, does this prediction hold? Let's see. Haynes-King throws the ball. That ball is leaving at about a 51-yard line or 49-yard line. And then the catch is made at the 11-yard line. That gives about 39.5 or 36 meters. That's a little short. What's up with that? We'll get to the error later. Or now, actually, the results of error. First of all, human tracking, me. I'm unlikely to place that tracking point exactly on the center of the football at every frame. That's difficult to do. Secondly, video artifacts. The rolling shutter in football is a fast-moving object, and the video compression may distort the video, as well as the perspective. It's not a shot looking straight on the football field. It doesn't have a perfect angle. Everything coming in linearly from all parts of the field. There's lens distortion. There's as you go out to the side, you're getting distortion from there. The angles are changing. I essentially just projected that 3D down onto a 2D small point in the camera, which is what a camera does. So I'm not really measuring in the third dimension, the Z, only the X and Y. And also air resistance. As you can see, I included that as part of the surroundings, but I did not actually include that in the calculations, which that would contribute to a few yards short, which is what the actual throw was compared to the simulation. Now, extra little cherry on top, the kinetic energy of that ball during the throw. When he releases that rock, it is almost 185 joules in that football. That's crazy. What an amazing throw. Just love to see it. All right, that's the end. Thank you for listening.